In this video, we're going to take a look at section 1.3, which is on applications and problem solving. In other words, we're going to be looking at some word problems. The difficulty with word problems is that no two are exactly the same. You can't do two different word problems exactly the same way. So each time you look at a word problem, there's going to be something different about it than any word problem you've seen before, and you're going to have to read through it and figure it out from scratch pretty much every time. So the best that we can offer is a method, a strategy for approaching these problems to help you work through it. And so this is what the textbook provides us. 5 steps for problem solving. First, you want to familiarize yourself with the problem. That means reading it all the way through, and I always recommend to my students to read the problem first before you even write anything down. So make sure you've read it all the way through to see what's going on overall with the problem, and then you can go back and start picking through the details and writing things down based on what you read. Ultimately, what you're trying to accomplish, and so step 2 is a bit of an oversimplification, is you want to translate the problem into an equation. That's what every word problem is about, taking all these words and figuring out what the math looks like for it. And that's the difficult part. And so we're going to talk about some strategies for trying to make that a little bit easier to do as we look at some of these examples. One piece of advice I have for this step is to let the variable, x, whatever letter you want to use, be the thing that you know the least about in the problem. There can be a tendency to let the variable be the thing that you're looking for, but that's not always going to make the math the easiest to set up. It's always easiest to set up if you let the variable be the thing that you know the least about and work from there. Once you get an equation established, you want to solve that equation. That's step 3. Once you've solved the equation, you have an answer for x. Check the answer in the original problem. That really just means make sure it's a sensible answer for the situation. So if you're solving an equation and you're looking for the price of an item, and you solve the equation and you get x equals -5, that answer doesn't make sense for that situation. The price cannot be a negative number. Many students try to fix an issue like this by adjusting the answer to something that does make sense. That normally doesn't get you the right answer either. So for example, a lot of students would say, oh, -5 can't be right because the answer can't be negative, so the answer must be +5. I'll just drop the negative sign. That normally doesn't fix it. If you get a negative answer when you're not supposed to, it means there's something wrong with the equation, not with your answer. So you can't fix it from the answer. You have to go back to the equation and fix it from the equation. Supposing that your answer does make sense for the situation, you then want to actually answer the question in the problem, because the solution to the equation isn't necessarily the answer that you're looking for in the problem. So take your value for x, make sure you understand what it's telling you, and then use that to actually answer the question in the problem. All right, let's look at some examples. So I apologize for the resolution on these problems here. These are images that I took from the homework that I put on a PowerPoint that I then converted to PDF, which I then imported into this program that I'm using to make these videos. So it's gone through a few different translations, and I've obviously lost some of the quality in doing that. So if you're on a large enough screen, I would recommend blowing up the video to full size on your screen. That might make it easier to read. I'm also going to read the problem to you, so maybe that will be sufficient for whatever device you're using to be able to follow along with the problem. So here's what the problem says. An appliance store decreases the price of a 19-inch television set 27% to a sale price of $455.16. What was the original price? Right? So we're talking about a very common situation that we've all encountered. An item is on sale, and they're advertising the sale as a certain percent off of the original price. And we see what the sale price is, right? So we're being told here the sale price is $455.16. That's how much it's on sale for. We're being asked to work backwards to figure out what the original price of the item was before it went on sale, based on the fact that the sale is 27% discount. And so a very common mistake students will make on a problem like this without thinking it through, whether the numbers make sense in this way, is they'll take whatever percent they're given, times whatever number they're given, and they get an answer based on that, and then they try to make sense of that number to get the answer. For example, they might take 27% of the $455 and then add that to the sale price to get back to the original price. That's not how we're going to get the right answer here. That will not give you the correct original price. So be careful not to just jump into taking the numbers you're given and slapping them together. We want to take our time with this, and so we want to set up an equation using the different components of this problem. And I would recommend a strategy for trying to figure out what the equation should look like is to make what I call a hybrid statement, which is a statement that is using words but connecting the words together using mathematical symbols. So it's like half math, half words. So for every sale has this particular relationship. There's the original price of the item. So let's write that out in words. We're not going to use variables or any kind of math or anything or any numbers. We have the original price of the item. And then when it goes on sale, there's going to be a discount. So we're going to take off a certain amount from that original price. That's going to be our discount. And that's going to give us the sale price. So anytime an item is put on sale, this is what's going on, right? Now, let's think about what we know, right? We know the sale price of the item. That's given to us. It's $455.16. So we don't need a variable to represent the sale price. It's a known quantity. And so let's go ahead and replace those words with the number that it's equal to. The sale price is $455.16. All right. These two words, the original price and the discount, we actually don't know either of these. We don't know what the original price was. That's what we're looking for. We don't actually know the discounted amount. We know the percent that it was discounted, but we don't know the dollar amount of the discount. And that's what this is representing. This is how many dollars are taken off the original price to get to the sale price. We don't know the dollar amount for that. But we do have some information. We do have a clue about that, right? It's 27% of, whoops, I don't know why I'm writing 29, 27% of the original price. So we have a clue about the discount while not knowing what it is completely. We have no clue about the original price, right? No details are given about this whatsoever. So since these are both unknowns, I need to use a variable. My advice a moment ago was let your variable be the thing that you know the least about. We know the least about the original price. And so I'm going to let X represent the amount of the original price of the TV. Minus, because we have a minus sign here, the discount, which is 27%. And anytime you're going to put a percent into a mathematical equation, you always want to convert it to decimal form. So 27% would be 0.27 of the original amount of the TV. I keep saying original amount. I should say 27% of the original price of the TV, which we don't know. But we now have a label for it. We're calling that X. So we want to take 27% of the original price, which we are calling X. To take 27% of X, you simply multiply those two things together. 0.27 times the original price, which is X. So we slowly translate these words into an algebraic equation. We have the words connected together mathematically. So the equation's kind of already there, right? We already have an equation here. There's an equal sign. But we're using words to represent the different components of that equation. And then slowly, one thing at a time, we replace the words with numbers or variables. And then we end up with a completely algebraic equation, which we can then solve. All right, so now we want to solve this equation. So moving on to step 3 of the strategy we just talked about, we want to solve this equation. And to do that, what we're going to do first is simplify the left-hand side. These are both like terms because they both have an X, so we want to combine these together. This one gives students a little bit of a hard time, because if you're combining, for example, 4x plus 3x, we're used to that, and the numbers are kind of nice and cooperative. We take 4 plus 3, we get 7, then the variable part just stays x. We're going to do the same thing here, it's just the numbers are a little bit more difficult to work with. We have 0.27, and in front of this x, we have nothing, which means there's an invisible 1 there, right? So we're going to do the same thing. We're going to take 1 minus 0.27, which gives me 0.73. And then the variable part, just like it did up here, the variable part stays the same. We'll have 0.73x equals $455.16. And now we can get x by itself by dividing by 0.73 on both sides. And we'll get x equals, I don't have a calculator. I actually did this problem earlier. I started a video, didn't like how it was turning out, so I stopped and started over again. So I have the answer for this, but I can't remember what it was. I think it's 622. All right, so let me get my calculator here. Okay, what's my phone doing? Okay, calculator. I'm using my phone, which is okay on the homework if you want to use your phone on the homework as a calculator, because usually most phones will have a calculator app. But if you're taking a test in my class, you will not be able to use your calculator. Sorry, you will not be able to use your cell phone as a calculator when you're taking the test. So you want to make sure you have a standalone calculator. I was pretty close. It's $623, and it wants us to round to the nearest cent. So that means 2 decimal places. Right? So 0.5. My calculator says 5068. So the second decimal place is a 0, but because the third one is a 6, we want to round up. Right? So we're going to round it up to a 1. And that tells me what x is equal to. So that's step 3, solving the equation. Step 4 is checking the answer. So we have to kind of have an idea of, well, what did we just find out? What does it mean for x to equal $623.51? So I go back to where I was setting up my equation, and that reminds me that x was representing the original price of the TV. And 623.51 seems like a reasonable answer for what it's representing. Right? It looks like a dollar amount for something. It's more than the sale price, which it should be, right? So the sale price should be less than the original amount, right? So if this is the original amount, this is the sale price, that all kind of makes sense. So it seems like a reasonable answer for the situation. And then step 5 is answer the question in the problem, which is what is the original price, which is the value for x, $623.51. So this time we look out, and x is the answer that we're looking for. So this would be my final answer. All right. Let's take a look at another problem where things are going to be a little bit different. A piece of wire, 92 centimeters long, is cut into 2 pieces, each to be bent to make a square. So we're taking one wire, cutting 2 pieces out of it, and each piece will be folded into a square shape. The length of a side of one square is to be 3 centimeters longer than the length of a side of the other. And so one square is going to be bigger than the other square. Right? One's going to be 3 centimeters long, or one square will have sides that are 3 centimeters longer than the other square. So how should we cut this wire to make 2 squares that have this relationship, that one has sides that are 3 centimeters longer than the other? So this is a pretty tough problem to unpackage. My advice to you on problems like this, if they mention any kind of shape, like a square, triangle, a circle, is to draw a picture. So I'm actually going to draw 2 pictures here because we want to have 2 squares, so maybe we could start with that. Right? We're going to have a smaller square and we're going to have a bigger square. And these squares are going to be constructed from a piece of wire that's cut into 2 pieces. So I want to draw this wire. I'm going to try to draw a straight line here. It's kind of hard to do. Whoops, I hit the wrong button. Sorry about that. Oh, now I can't undo that. Let me erase what I just did here. Sorry about that. So let's draw a line. See if I can do a little bit better here. Okay. So this is, okay, I'm going to try one more time. Make this line as straight as we can. Okay, that's not too bad. And wires can be a little bit, bent in places, so that's fine. All right, so we're going to take this wire. It's 92 centimeters long. We're going to cut it into 2 pieces. Now, it's a very common misconception, assumption that people make when they say we're cutting something into 2, that it means we're cutting it into halves, which we are not doing. We're not cutting this into 2 equal halves. The problem doesn't say that. And it wouldn't work for the situation anyways. If we cut this exactly in half, each side would have an equal length. The squares would be equal to each other. We don't want the squares to be equal. We want one square to be bigger than the other. So we're going to have to cut this wire to make a small piece and a large piece, or in this case, a shorter piece and a longer piece, whatever kind of terminology you want to use. And so when I'm going to draw where we're going to cut the wire. I'm going to draw a line where we're going to cut it at. I don't want to put it exactly in the middle, not only because the problem doesn't say we're cutting it exactly in the middle, but I don't want to fool myself later on into thinking that was what the problem said. So if I drew my line right in the middle, later on I might assume the two wires are equal length, which is not the case. So be careful that your drawing doesn't mislead you in some way like that. You don't want to make assumptions that aren't actually there in the problem. So I'm going to draw the line, let's say right here. So we're cutting the wire along this line right here. And so we have a shorter piece and we have a longer piece. The shorter piece is going to be folded to create this square right here. The longer piece will be folded to create this square. All right. And so that's the situation. Now, what I would recommend letting our variable represent is looking at the description of the square. One square will have sides that are 3 centimeters longer than the length of the side of the other square. And so the bigger square, the one that's 3 centimeters longer on the sides, we have some information about, right? This clue applies to this square right here. We have no clues given about the lengths of the side of this square. So we know less about this one. So this is the one we're going to let our variable represent. We'll let x represent the length of the side of the small square. And then the clue tells me that the length of the side of the bigger square will be 3 centimeters longer than that. Not 3 centimeters exactly, but 3 centimeters longer than whatever this one is. So if this one was like 2, for example, this one would have to be 5. It'd have to be 3 centimeters longer. It'd be 3 more than that. If this one was 7, this one would have to be 10, right? So that is the relationship there. So if this one's going to be x, this one will be 3 centimeters longer than that, which will be x plus 3. And what makes a square is the fact that each side has the same length. So if this side has a length of x plus 3, then all 4 sides will have a length of x plus 3. If this square has a length of side x, I said that backwards, didn't I? If this square has a side of length x, that sounds better, then all 4 sides will have a length of x. And then all 4 of these sides are constructed from this piece of wire. So this one small short piece of wire has to cover all 4 sides of this square. So if I take all 4 sides, which is 4 x's, right? There's 4 of them. If I add them together, that gives me 4 x's altogether. That has to match up to the length of the shorter piece of wire. Right? So if I add 4 sides here, that's how long the shorter wire has to be to make that square. The same thing is true here. It's a little bit more complicated mathematically, but if I take all 4 of these x plus 3's, that's how long the longer piece of wire has to be in order to make that square. And so now I have a measure, a mathematical expression to represent the measure of the short side of this wire. I keep calling it side, and that's probably not the best word to use here. I have something to mathematically represent the length of the short piece of wire, and I have something to mathematically represent the length of the long piece of wire. Now, how do I make an equation out of that? Well, I don't know if you maybe looked over this detail, but at the very beginning of the problem, we're told the total length of the wire is 92 centimeters. So the total length of the wire from one side all the way to the other side is 92. So if I take the short side, I said short side again, if I take the shorter piece of the wire and add to it the longer piece of the wire, those two would have to add together to give me the total length of the wire, which is 92. So there's my equation. So I didn't use words this time to represent that. I could have said the short piece of wire plus the long piece of wire has to add up to the total length, which is 92. So maybe that's not a bad idea to go ahead and do that. Sorry, my handwriting's getting a little erratic here. So the short piece of the wire is represented by 4x. The length of the short piece of wire is represented by 4x. The length of the long piece of wire is represented by 4 times x plus 3. And together those are going to add up to 92. And so there's my equation. Now I will solve this equation, right? Moving on to the next step. And to solve this equation, the first thing we're going to want to do is get rid of the parentheses. So we distribute the 4. And we get this. And before we start moving things from one side of the equation to the other, I always find it helpful to simplify first. So we'll combine like terms here. We get 4x plus 4x, which is 8x, plus 12 equals 92. And now we solve this by subtracting 12 from both sides. And we get 8x is equal to 80. And not that this has to work out to be a nice answer. You know, the length could be 7.238, right? That's not a bad number for a length, but it is a nice sign when it does work out to be a whole number. So dividing by 8 on both sides, we get x is equal to 10. So that is solving the equation and getting an answer for x. And that answer seems to make sense. You know, the total length of the wire is 92 centimeters. So we're going to make one square have a side measuring 10 centimeters. That seems reasonable for the numbers that were given. So step 4 kind of checks out. That's a reasonable answer. It's not negative, and it's not like 100. That wouldn't be a good answer, right? Because the wire is only 92. We can't have an answer of 100. So we have a sensible answer, right? Now, does this actually answer the question being asked in the problem? And the question being asked in the problem, and I think there are actually 2 questions, even though only one is showing up here, is what is the length of the shorter piece of wire? And a lot of students will say, well, it's 10. I got x equals 10. My answer is 10. But x is not representing the length of the shorter piece of wire. X is representing the length of the side of the square that is created with the shorter piece of wire, right? X is representing this here, right? So let me pick a different color here. So this right here. Right? This is 10. So this square is 10 centimeters by 10 centimeters. That is not the length of the shorter piece of wire. So to get the shorter piece of wire, we have to take whatever x is equal to, which is 10, and plug that in here to find out the length of the shorter piece of wire. And so for the length of the shorter piece of wire, it's going to be 4 times x. In this case, x is equal to 10, so we'll get 4 times 10, which is 40. And that's the answer you want to type in here. So the shorter piece of wire needs to be 40 centimeters. So what does the longer piece of wire have to be? You could plug in 10 here for x to find the length of the longer piece of wire. But the easier way to do it is to use the total length, right? The total length is 92 centimeters minus 40 for the shorter piece of the wire. And that leaves me with 52 centimeters for the longer piece of wire. And that adds up to 92 altogether. So the longer piece of wire is going to be 52 centimeters. All right, so I'm sorry that took a long time to get through. Maybe I could have went a little bit quicker. Maybe I over-explained in some areas, and I apologize. I'm getting a little tired. This is my 3rd video in a row, so I'm getting a little bit tired on this one. Maybe a bad one to get tired on with the word problems, but I'll try to do better on this next problem. All right, so let's take a look at another example. All right, a certain real estate firm, sorry, I left out a word. At a certain real estate firm, realtors selling homes receive a commission of 9% for the first $140,000 of the selling price and 8% for any amount exceeding $140,000. A realtor for the firm received $12,840 for selling a house. What was its selling price? Right. So there's a lot of numbers being given here, but I would recommend putting this equation together using words, right? Rather than worrying about the numbers. So what are the different components that go into determining this realtor's commission? Right. So the amount of the commission, using words, is calculated. It's going to equal 9% for the first $140,000 of the selling price of the house. And so in addition to that, plus 8% for any amount over $140,000. So that's it. That's how their commission will be calculated. So we know the amount of the commission for this particular realtor. We're told in the problem this realtor made $12,840 for selling a house. That was his commission, his or her commission. And so that's a known value. We don't need a variable for that. We use the number to represent that, right? So the commission is a known number, so use that number for the commission. Equals 9%, which remember I said on the last problem a couple problems ago, 9%, whenever you're doing percents in word problems, you want to convert those to decimal form. So 9% is 0.09, not 0.9. I get a lot of students that put 0.9. That's 90%, right? So 0.09 for the first $140,000 of the selling price of the house. So assuming the house sold for at least that much, they're going to get 9% of that full amount, of the full $140,000. Which I think is safe to assume that this house sold for more than $140,000. So they'll get 9% of that full amount. Plus, so there's no variable there, right? Because it's known that, you know, we know it's all for the, how do I want to say this? It's for the entire 140,000. So it's a known number. This is the part we don't know. It's 8%, 0.08, for any amount that's over 140,000. So we don't know how far over 140,000 that this house sold for. And so we'll use a variable to represent that. Now I'm going to warn you, and I think my way is easier, but Math Excel, if you're going to look at your homework examples, they set this up in a different way. They take into account that 140,000 here. They set it up in the equation. It makes the equation a little more complicated. It makes it nicer once you get the answer, but I think it makes the equation more difficult, and so I don't like it. So I like to do it this way. I keep it simple. I'll just let X represent however much it was over 140,000. So keep that in mind, that my X here does not represent how much the house sold for altogether. It only represents the amount over 140,000. So when we find our value for X, we have to keep that in mind. So here's my equation. So I want to solve that for X. So I'll start by simplifying. I'm going to take this 0.09 times 140,000 and multiply those two together. I almost want to try to do this mentally, but I don't know if I'm up to the task right now. So let me get my calculator. We have 0.09 times 140,000. It gives me 12,600. This part stays the same, 12,840. Plus 0.08 times X. We'll go ahead and put those closer together. And we'll solve this for X. We'll subtract the 12,600 to the other side. So the 12,000 goes away. We'll have 240 left over from that. Equals 0.08x. And then to solve for x, it might not quite fit on the screen here, but I'll try. But you divide by 0.08. Divide by 0.08 on both sides. And we'll get, so 240, use my calculator, 240 divided by 0.08. And we get 3,000. So I'm going to write the answer over here. So we get x is equal to 3,000. Now, some of these problems, because, you'll have a very similar problem to this on your homework, but the numbers will be different. And sometimes you'll get numbers where this answer can fool you if you set up the problem the way I set it up. So you might get something like x equals 120,000. That's a pretty big number, and that's a reasonable number for how much a house might sell for. And so you might fool yourself into thinking, well, then that's my answer. That's how much the house sold for. But remember, x, the way I set up my equation, does not represent the full amount for the selling price of the house. It's just the amount that was over 140,000. Right. So the house sold for 3,000 more than 140,000. So if I put that information together, there's the initial 140,000, and then x tells me how much over that the house sold for. So it sold for 3,000 more than that. So I add that to that amount, and I get the final selling price of the house, which is 143,000. So you have to add back that cutoff value to whatever you get for x to get the total selling price of the house, if you're going to set up the equation in the way that I have. If you follow Math Excel's example, it sets it up, it lets x represent something different. It's a more complicated equation, but once you solve their equation for x, you get 143,000 as your final answer for x. So it just takes you directly to the final answer. So it's up to you whichever way you want to do the problem. But this would be the selling price of the house, which is what I was looking for. Okay. All right. Let's look at another example here. This is kind of a similar example, but let's go ahead and do it. A carpet cleaner charges $75 to clean the first 180 square feet of carpet. There is an additional charge of 25 cents per square foot for any footage that exceeds 180 square feet, and $1.30 per step for any carpeting on a staircase. So this is how their bill is determined. All right, so let's go ahead and let's read the problem first. Right? Let's follow my advice. So read the problem all the way through before we write anything down. A customer's cleaning bill was $203.95. This included the cleaning of a staircase with 14 steps. In addition to the staircase, how many square feet of carpet did the customer have cleaned? Right. So we're going to set up an equation for determining how much this carpet cleaner is going to bill using words connected by mathematical symbols, right? Pluses, minuses, whatever we need to use. So the total bill that the carpet cleaner will send will be calculated in this way. There's a $75 flat fee, right, to clean, and that covers your first 180 square feet of carpet. There's an additional charge, so addition to that, we'll add 25 cents, so 0.25, for any square feet over that initial 180 square feet. So it's very similar to the last problem we did with the selling price of the house. And in addition to that, $1.30 for each step. So that's how your bill will be calculated. So we're told this particular customer had a total bill of $203.95. That information is given to us. It's not an unknown value, and so we don't need a variable for that. We just plug the number in place of those words. So the total bill, we already know what that is, $203.95. We'll copy down the $75 fee plus 25 cents for each square foot over 180. I'm going to let X represent that. Again, Math Excel incorporates the 180 into the equation here. I like to just leave it to the end, right? I'll let X represent however much the square footage was over 180, and then I'll add back that 180 at the end of my problem instead of trying to integrate it into the equation here. Plus $1.30 for each step, which we don't need a variable for this. Even though this looks like something you might want to use a variable for, we know what this is, right? We're told for this particular customer they had 14 steps. So we just put in 14 there. There's my equation. So we need to simplify this and isolate X on one side, and we'll have our answer. Right? And so we'll go ahead and multiply 130. Let me get my calculator out. We have 130 times 14, which is 18.2. Right? That's what my calculator says. Now, but we're dealing with money, right? This is $1.30 for 14 steps. That'll be $18.20 for all those steps. So even though mathematically I could put 18.2, I like to put the 0 there because we're dealing with money and it just looks more like a dollar amount if I do that. All right, the 0.25 is not going to change and the 75 is not going to change. So I'm just copying all this down, 203.95. And before I start moving things from one side to the other, again, I like to make sure everything's as simplified as possible. We can combine these numbers together. So we have 75 plus 1820. That's going to give me 203.95 equals, when I add those two numbers together, I'll get, what, 85, and then another 8 would make that $93.20 plus the 0.25x. Now I'm ready to move that number to the other side, so I'm going to subtract the 93.20 over to the other side. And so I should be able to do this. I don't know. I should be able to do that in my head, but I just feel like using a calculator. I'm not mentally up to the task. Minus 93.20 gives me $110.75. $110.75 equals 0.25x. I'm sorry, I'm running out of room here, so I had to continue the work over here. And then we will divide by the 0.25 on both sides. And let's see. I'm trying to see if I can make more room on the screen. I'm pretty sure there's a way to do that, but I don't remember how at this time. So I'm just going to squeeze the answer in over here. Maybe I'll figure out later before I do more videos. So, well, let me do the calculation first. So we have 110.75 divided by 0.25. It's going to be 443. So let's write the answer right here, 443. So what x is equal to? Seems like a reasonable answer, right? It's not negative, because again, negative answer would be nonsensical here. And it seems reasonable for a square footage. Right? A house typically has, I don't say average size house. I don't know. Maybe average isn't the right word to use there either, but 1,000, 2,000 square feet is a typical size for a house. So 443 square feet of carpet to clean, that sounds about right? So it's a reasonable answer. But to answer the question in the problem, what's the total number of square feet that was cleaned? And this 443 is not the total number of square feet. Remember, x was representing just the square footage over the first 180 square feet. So this is how much over 180 was cleaned. So we have to add that 180 back to that to get the total of square footage that was cleaned, right? There was the initial 180 square foot that was cleaned, and this was the extra that was cleaned above and beyond that. So if we add those together, we get 3 here. I think I can do this one in my head. 2, and then 5, 6. Right? So we get 623 square feet, which is the total amount of square feet that was cleaned. So that's what you would want to type into Math Excel. All right. If you don't like having to do this little bit at the end, if you want your answer to come out of the equation directly, then I would recommend looking at Math Excel's example, and they'll show you how to set up the equation where that happens. But it does make the equation more complicated, so I'm just going to warn you about that. All right, I have one more example here. This is a very common word problem, especially when you're introducing word problems for the first time in a course. Find 3 consecutive odd integers such that the sum of the first, 2 times the second, and 3 times the third is 58. So we want to add 3 consecutive odd integers together. So sometimes what I find helpful when I'm doing a word problem is to have a hypothetical answer to help me figure out how it all fits together. So maybe hypothetically speaking, what could possibly be an answer to this situation? What does it mean to have 3 consecutive odd integers? So an example of what that would look like would be 3, 5, 7. Those are 3 odd numbers in a row. That's what 3 consecutive odd integers means. You want to have, consecutive means in a row. You want to have 3 numbers in a row that are all odd. So this would be an example of that. Or you could have something like 7, 9, 11, right? That'd be another example of what we're looking for. But we're looking for 3 odd numbers, 3 consecutive odd numbers that fit this description here. That if we sum, meaning if we add the first one plus 2 times the second one, the second number, plus 3 times the third number. This will add up to 58. All right. So again, using our hybrid statement, using words with, connected together with mathematical symbols, this is the situation we're dealing with. We're summing, meaning we're adding these up. The first number, 2 times the second number, 3 times the third number. Those 3 things are getting added together because they're telling us to take a sum here. Now I need to use variables to represent this because I don't know what the first number is. I don't know what the second number is. I don't know what the third number is. So I need variables to represent these. My advice was to let your variable be the one you know the least about, but there's a tie here. We don't know anything about any of these numbers. We know, I should say, we know the same amount about each one. So it's pretty common to let x represent the smaller one, the first one. So I'm going to let x represent the first number that we're looking for, plus 2 times the second number, which I can't use x again because I'm already using it to represent the first number. I could use y to represent the second number, but then I don't want to have multiple variables. I want to stick with just one variable, x. So let's use this relationship up here. Whatever the first number is, how much bigger is the second number? It's always going to be 2, even though it's odd numbers. This is what throws students off. They're odd numbers, but this middle one is 2 bigger than the smaller one. Right? It's 2 away. Look here, right? The smallest number is 7. The middle one is 2 bigger than that. It's 9, right? So when you have 3 consecutive odd numbers, the middle one is always going to be 2 bigger than the smaller one. So if I'm going to let x represent the smaller number, the middle number would have to be 2 more than that to be the next odd number in a row. I don't know if I'm saying that right. So to be the next consecutive odd number, it would have to be 2 bigger than the smaller one, right? And so that's what I will use here to represent the second number in the 3 consecutive odd numbers. It's going to be 2 bigger than the first one, plus 3 times the third one. If you look at the third one, it's 2 bigger than the middle one, but that's not the relationship we want to look at, right? We're letting x represent the smallest number, so I want to know how much bigger the third one is relative to the smallest one. And if you look at the third one's always 4 more than the smallest one. So whatever the smallest one is, the third one in a row is going to be 4 more than the smallest one. Right? So x plus 4 is how we represent the third one. And then that's going to equal 58. And that's going to give me my equation. All right. So whenever you have consecutive odd numbers, this is the relationship between those 3 numbers. It's x plus 2, x plus 4. If there was a fourth one, it would be 6 more than the smallest one, right? It'd be x plus 6, and so on and so forth. All right. And now we have this equation, which we can now solve for x. So we'll copy this first x down, because the first task we have is to get rid of the parentheses. So let's distribute here. Sorry, it didn't quite work. Plus 2x plus 4, right? 2 times x is 2x. 2 times 2 is 4. Plus 3 times x is 3x. 3 times 4 is 12. Equals 58. Before I start moving things from one side to the other, let's simplify, tidy things up here. So we have several like terms. We have x plus 2x plus 3x. Those 3 things combine together to give me 6x. We also have 4 and 12, which we can combine together to give me 16. And now we have an equation to solve. We subtract 16 from both sides. We get 6x is equal to 42. And then, oh, that's kind of funny, isn't it? So we divide by 6 on both sides, and we get x is equal to, okay, I don't know why it's not writing here, x is equal to 7. All right, and so that's an odd number. That's a good sign. If we got 6 here, it's not a good sign because we're looking for odd numbers. We shouldn't be getting an answer that's even. We're also supposed to be getting integers, which means whole numbers. So if we got something like 5.5, that's not a good answer here either. Can't be a decimal or a fraction. So we have to be on the lookout for bad answers. But 7 is a good answer for this situation. The final answer is, and now here it says, what's the smallest of the 3? Well, that would be 7, right? X is representing the first one, which is the smallest one. But I'm sure it's going to ask you what the other 2 are. So the middle one is going to be 9, right? It's going to be 2 more than that, right? So the middle number is 2 bigger than the smallest one. It's the next odd number in the list, right? Which is 9. And then the largest one, so this will be the middle one, which I'm sure it's going to ask you about. And then it's going to ask you about the largest one. I'm sorry, my handwriting's horrible right now, which is going to be 11. And so this would be your 3 numbers. So I just so happen to write that down as a hypothetical answer, and it turned out to be the actual answer. That normally doesn't happen. All right, so this was the last example I had for this section. So this was section 1.3 on word problems.